And we are live. Hello, everyone. Welcome, everyone, to the Somnia Codelabs. My name is Emmanuel, and I am with the developer relations team here at Somnia. As always, it is my delight to anchor this sessions, and it is a pleasure to have you join us here again today. In this edition, we have a session on Protofire Subgraphs on Somnia, featuring a very special guest from the Protofire team. Hello, Aseni.
Hello, Emmanuel. Nice seeing you today.
Same here, same here. As always, it's a delight and a pleasure. So, Aseni, before we dive right into the session, please kindly share a brief introduction about yourself and what it is you do at Protofire.
Absolutely. So I'm Arseni. I'm the CTO at Chainlove, and I'm the what we call a field CTO at Protofire DAO. The Protofire DAO is the DAO that consists of over 100 engineers that deliver solutions that drive TVL growth and increase adoption. We are working since 2018. I was at the very beginning, at the very early days of Protofire, and we worked with 65 protocols, and Somnia, of course, is one of them. We ship a lot of different things like safe multisigs, oracles, the graph that I'm going to be showing today, staking modules, fork of like tier one, the 5 protocols, audits, DevOps services, so on and so forth. And I would give a bit more details about the things that we do, especially we will focus today on the subgraphs a bit later. But yeah, that's kind of a brief introduction that I'm having.
Awesome, awesome. Thank you very much for that, Aseni. Before we go right into the session, a couple of ground rules for the audience here today. Please send in your questions via the comments here on X or via the comments on YouTube, and we will answer them at the end of the session. Please be civil and keep your questions to the topic being discussed here and to any other technical questions that you may have about Somnia or Protofire subgraphs. Right now, I'm going to be handing over to Aseni to lead the rest of the session. Thank you, Aseni. Over to you.
Absolutely, thank you, Emmanuel. So today we are going to be working together with all of you guys to deploy a live application over the Somnia network, and we are going to show how extremely fast it is, how you could use the subgraphs to get the information from the Somnia network extremely fast. So we are going to deploy the application that will show basically the live competition between the people present here today on the call. Before I even begin, I will send you the link to the all materials that I'm having here today, that I have prepared, because for 2 reasons mainly. Emmanuel, if you don't mind, could you send this to the audience? I'm not sure
Yes,
how
please.
to do that. I have sent it to your, yeah, thank you. So basically, for 2 reasons. First of all, you could do it together with me. This is a good, the good thing for you if some of you want to, verify that everything works exactly as I claim it to work, right? And the second is, of course, after the stream, you could do it yourself. You could try and see how it works. You could understand the code that we are going to be writing today, and so on and so forth. Also, just to not to take a lot of your time, we are going to skip some of the steps. For example, I'm not going to be rewriting the libraries that I'm using in the application, but it's fairly simple. I mean, like, I don't think there is any reason today to write the cascade style sheets code, like the styles of the application or something like that, or the wallet connect, which is basically it's the same everywhere. These are going to be just like a couple of files that I'm going to simply include in the code, and we are not going to be focusing on or stopping on them. They are in the repo. You can read them, but they're well, basically they are everywhere the same. There is nothing to even talk about it there. So before we even begin, okay, I'm going to explain about a couple of words about the chain love, because I was mentioning about the Protofire and about the chain love. The chain love is kind of a spin-off that we are spinning as a separate business, and I want to give you an introduction on what we are doing in the chain love. For that reason, I'm going to present you my screen in a second, just for a minute of a time. So basically, the chain lab is something that you can consider as a one-stop shop for the Web3 infrastructure or for any services. Imagine you're starting, like you're a new developer. You're coming to you're coming to Somnia and you want to start developing. How do you know what are the RPC that are available on Somnia? Well, you have to Google for that, right? Or have to read the document. How do you know what are the indexing that is available? What are explorers that is available? Of course, you could read the documentation, you could read the information like that. But what we are building and what we are going to bring to Somnia as pretty soon is going to be a dashboard where you could already read all the information about what the services are available at Somnia Network and what are the different metrics that you could compare in between. So the one other important part is like when you're developing an application. Today we are going to be developing an application that will show you a delay of less than 5 seconds between the transaction being sent to the network and the actual data being displayed on the website. Like, how do you, even for example, imagine you have like 5 indexers, 5 RPC providers, whatever. How do you understand which of them can provide such an SLA, I would call, like, or uptime guarantees or latency guarantees, right? So the idea behind the chain lab is to show you the different options that are there and to provide a reliable information source for the different metrics. For example, which of the providers provide better SLA guarantees, which of them provide any guarantees. Maybe some of them, even provide hard, financial guarantees that they will provide a good services or something like that. Because it affects everyone, especially right now in Somnia we are on the test stage, so some of the errors are expected, right? When we go live, it is pretty much important that we are very, very committed to the resilience of the network, right? And it is important that we are providing as resilient service as possible. So ChainLove is aimed to basically give you a clear understanding on what services to use. Having that said, I think we could switch to our main topic, which is developing the application together, which will start with developing the smart contract. So how it's going to work? We are going to write a super simple, the key ISS principle. Keep it simple, these kind of things. We are going to develop a super simple smart contract. The only thing it will do is it will accept you as a sender of the message, and it will increase the counter that starts from 0, and it will increase your counter from 0 to 1, next time from 1 to 0, so increment basically. Next, we are going to develop with you today the subgraph. Also a pretty simple one that is going to use the smart contract and is going to fetch the information from the smart contract. The third thing, we are not going to be really developing the website itself. I'm going to show you how I wrote the code, how I wrote the application. Frankly speaking, I'm not going to be, lying here to you. It's mostly was wipe coded because basically it's a super simple app. I just didn't want to even spend a lot of time, and it's a simple, straightforward code that is reading the information from the subgraph and is presenting on the site. At the end of the presentation, we will play a very fun game. We are going to be competing on who is sending more transactions and who is getting a higher counter. And for that, like the winner of this small funny competition is going to receive a small present. So having that said, let's begin and let's dive into the writing of the smart contract. I'm not going to be diving very deep into what we're doing because I also know, like, on the Somnia YouTube channel, there is a video recorded by Emmanuel that is already providing information on how they use the Remix IDE to write the smart contract and deploy it on Somnia, right? I'm going to just explain you the code that we are having here, and explain you why we wrote the thing that we wrote in the way that we wrote, right? So let me share my screen. Okay, I hope you all guys see that. So the code is fairly simple, okay? What we do is we map the user with the counter. So there is an address, and we add the variable that is just counting the number of interactions, right? And we have the Boolean variable here that said that the address has interacted already. This is very important because later in the contract we are verifying if the user has already interacted with the smart contract, then it exists in the smart contract, and we need to fetch the information from what his current counter and increase it. Otherwise, what we are doing is we are adding the user to the to our basically database, and we are setting his counter to 1, which means 1 interaction, his first interaction. Okay. So here we go. Let me probably zoom a bit out. Yeah, I hope that's seen good, still good enough. And move further. So this function is called to increment. As I was saying, we are verifying that user has, if the user did not interact with the smart contract before, first thing that we need to do is to add the user, right? Then we need to set his has interacted to true, so we are not repeating and going through the cycle over and over again. Then we are increasing the counter of the message sender, and we emit the event. This is a very important thing because subgraphs are designed to listen for the events emits and get information from these events emits. Basically, if you want the subgraph to record some information, it is crucial you use these kind of things. And we have a couple of supportive functions like getting the current counter, so we could read the information online, get the number of users, and basically get the specific user by its index. This is a 33-line smart contract. If you have any questions about how this some smart contract works, just let me know in the chat. Otherwise, I'm going to just go ahead and deploy it live in the. I'm going to compile it now, and I'm going to deploy it live on Somnia network. Okay, I'm on the Somnia testnet at the moment. I'm having enough tokens. That's great. Let me go to the deployment part, and I'm using the injector provider here to actually deploy this smart contract. All right. I'm sending this transaction, and I'm getting basically the address of the smart contract. We will need this address of the smart contract later to actually use it in the subgraph creation process. So now, as a next step, we will go and create a subgraph that is going to be reading this smart contract. This is a fairly simple thing. You could do it online via the CLI. So let me share my screen and go through this process with you. Okay, and window, and sorry. All right, cool. So the one thing that you will need to be installed is the Graph CLI. It's a very simple to install it. Basically, the only thing that you need to do is to have either a yarn or npm with you, and you just go and install, for example, using the npm, the Graph Protocol CLI. Graph Protocol at Graph CLI at latest. This is pretty much the command that you would use. I'm already having the Graph CLI installed here, as you can see, so I'm not going to be reinstalling it, but it's a fairly simple process. The npm is, again, like to run the npm, you will need the Node.js to be installed, but yeah, that's pretty much the story. Now, to initialize a subgraph, you simply, what you do is you write a graph init, and you write from, I think, yeah, you write the from contract, and you write the contract address that we have deployed a few seconds ago. Then network is equal Somnia testnet. And the other thing that you will need to have is an ABI. The ABI is basically the interface of the smart contract. Let me show you what is, according to my own, where I'm usually getting the ABI from. To get the ABI, you can simply go and verify your smart contract via the Block Scout Explorer. Let us do it live. Here we go. And yeah, basically, I opened the address that I got from Remix ED, and I'm clicking verify and publish. Here, I'm not using any license, and I'm using only one Solidity file, and I have the code of the contract here with me, and we use the Solidity version of 8.0.19. And all right. Let's wait a second. I think, yeah, we also. Sadly, something is not working as expected here. Usually I'm using this method. Yeah, something is failing here, unfortunately. I usually use this method, but what I can do is to simply provide you with the ABI. The ABI is just like a set of methods that you could use to call the smart contract. Here, in the Somnia demo folder that we have shared the link with you already, in the subgraph folder, you could go to the APIs, and here's the counter.json, which provides the information about the methods that we have on the contract. Remember, I was showing you the functions of the contract. Here we have pretty much the same: get counter, get user count, get user rate. It's just like a JSON explaining how you interact with the contract. There are several other ways of getting the APIs, but we are not going to be covering it as a part of this demo. It's pretty much like the standard thing that exists everywhere. Now, having that said, we are going to use this API that I'm going to save as the file. And we are going to get back to creating the smart contract. Nice. So getting back to writing this comment, the API is api.json. The name of the subgraph doesn't really here matter, but we are going to write demo live, whatever, and we are good. So we choose Ethereum for the protocol because it's basically not Ethereum as Ethereum, it means EVM compatible, okay? We choose the hosted service here, and it doesn't initialize for that. Oh, great. Not really great, but anyways. I think it still should work if you choose the, yeah, I think it should work. The start block. The start block is basically the block where your contract has been deployed. It also can be taken from Remix EDE. You just see the transaction log on when it was deployed. In my case, I'm going to show you here on the Remix EDE. That's basically the block that it was deployed is 107,351,838. You could copy it here. Getting back. The contract name doesn't really matter from what I remember, so we still use the word counter. Yes, and we initialize the repository. In the meanwhile, while it's downloading the dependencies, any questions, anything that I may answer in the meanwhile?
So the questions will come in via the chats, and then once we do, we'll answer those questions. But in the meanwhile, you can also talk us through the process.
Yeah, I will. For now, since we are having the dependencies installation, let's get to the other part of this process. Is basically how you will deploy the subgraph. And then once the subgraph will initialize, we'll get back to developing it and then upload it. So let me share the screen again. I will open here. So okay, here we go. This is the somnia.chain.love website, where this is provided by ChainLove, by our team, which allows you to deploy to get access to the RPCs and to deploy your subgraphs. You could connect to it via one of the three methods here. It's either MetaMask, GitHub, and Google. I'm strongly recommending it to do it via the GitHub because when you do it via GitHub, we kind of can verify your identity. It's pretty much skips the process of creating the subscription. If you use the other method of authentication, you would have to activate the subscription. It is free, as you can see, but still you will have to like provide your credit card details just so we could let you create the the subgraphs, it is a kind of a DDoS protection measure. The creation of the subgraphs is completely free. It is subsidized for you by the Somnia network. So you click here the create of the subgraph, and you could name it, well, we'll name it counter again, right? You can make it private or public. I'm just go with public. I don't care. As you can see, by the way, there is one that is already here. It's called demo that I was creating yesterday, and it contains pretty much the same code. So you see the counter increments, the users, and everything. We could see here the information. That's pretty much, by the way, a very convenient way to interact with the existing smart contract of yours. Starting with that, you could update the new versions, like you could easily upgrade the smart contract, the subgraph, if you change something inside of your contract, for example. You could push the indexation, you could delete the versions, you could get the examples of the usage of your subgraph in different code, in different languages, programming languages. And what is even better, you could use the Explorer to play with the queries. The Explorer is really fantastic because it allows you via like the simple clicking mechanism to provide the way of how you actually interact with the smart contract. So for example, imagine like this one is deployed for the smart contract I was deploying yesterday. We will deploy them very similar today, but for now let's interact with this one. For example, I was using yesterday, I remember, 2 accounts to verify that everything works as I expected to work. Right, and then I click a query, my query first, for first end users, and I get the information about the first end users of my contract. Here it was only 2, obviously, but well, if it were 10, you could get it 10. And one of the most significant achievement of the subgraph is not even a speed; it's the complication of the queries that you can have. For example, here you could not only set the like 10 first users, right? You could actually go with filtering them by ID. You could filtering them by when they were updated. You could actually combine the filters, so you're not only getting like their IDs. You can also order them by basically by different fields that you're having here, right? For example, you could also get like their the ID and timestamp of their increments. So when the user were interacting with the smart contract and at what timestamp that happened. You could even basically order by this timestamp. So there are a lot of things that you could do. And what is great is that you don't even need to understand how to code to play with the subgraph, because initialization of this smart contract is fairly simple. As I was saying, you just download the CLI, you click graph init, you provide the data, and it's pretty much initialized, right? Then you deploy it, and you are super pretty much happy with it. What is great about the initialization command is that it will provide you with the basic information about smart contract without you writing anything. It will already give you a lot of base thing, and unless you want to write some advanced code, you can do it as is. So yeah, having that said, and also, of course, as I was saying, like here you could make your subgraph private, so only you would be able to access it if you just don't want to share it with anybody else. So getting back to the counter, we created our subgraph. Remember, I was clicking here, writing the name. The counter is here. You go here, and it will immediately provide you with the information on how to actually deploy your subgraph with all the steps. Remember that we were starting with adding the graph CLI, with basically graph code gen and graph build commands that are important for building the subgraph as well. Let me get back to since the dependency is already installed, let me get back to the code. So here, after the initialization, I also launched the graph code gen and graph build to build the subgraphs. It will provide you the basic necessary information. So, for example, this is the structure that you already get. You will have the Docker Compose here, and you could check the couple of important files. For example, subgraph.yaml. You see that the network here is Somnia testnet. This should always be the same as on the UI. It's if you remember, on the website we are having the name here, right? So it's Somnia testnet counter. The counter is the name of the subgraph, but the network should of course be the Somnia dash testnet. And what else is important? The address of the smart contract is correct. Okay. The start block is correct because I have provided it when I was initializing it. And then the another thing that you would likely want to do is to verify that the code written in the code that is written in the SRC folder is also correct. So we will update it slightly. Let me get to. You could check the information of how it's written in the subgraph src mapping.ts file, right? The how it's generated by default is okay, but I want to, let me check. Yeah, I think it doesn't provide still the increment ID. Oh no, the counter incremented. Okay, I think let's try to, first of all, let's try to deploy it as is, or we will, if it doesn't work as is, we will slightly patch it, and I will show you also how to deploy the new versions. So getting back to the website, you are seeing here the instructions. After we run the graph code gen and graph build, you see the graph deploy command. It contains your access token. Don't show it to anyone. Well, it's still just the way you access the subgraphs. But basically, I will show you my token. Feel free to copy it. I will delete it after the demo anyways. And let me get to deploying the subgraph. Here you go. We are compiling it, uploading to the IPFS, and deploying to the graph node. Voila, it's as simple as that. Now, let's get back to the website. Here, as you could see, there was an instruction on how to actually deploy the subgraph. Once you deploy it, it immediately changes to the playground, and you already see here the counter incremented, the counter incremented fields that is going to be indexed. And here, the one thing that we are still missing is the information about the user, who have increased the data, right? So the subgraph is fetching the counter, but it's not fetching the user information. To do that, I'm going to slightly patch the code. Basically, I'm going to simply take it from the mapping.ts file, and feel free to or let's do it actually together. It's src.counter.ts. So here you go. let's add the user ID and the information about the user. Okay, so first of all, the user ID is going to be his wallet. So what we do is get the event. Remember, we were emitting events at the smart contract side. We go to the parameters, we go to the user, and we have 2 hex string. Then we go to define the user. The user is something that we try first to load via the user ID, meaning that we try to find it if it already exists, to not to recreate it. And if the user is actually does not exist, we create a new user. And we set, we first initialize the user counter to 0, which is big int from I inserted to 0. I think I also missed here the opening brackets. Good. Next, we update the user that we either created or loaded with the information about their new count, which is current counter of the user. Then we update okay, so yeah, we already have it here. You know, it was generated automatically, so I don't think we needed to do it. The only thing we use it, okay, it's here. It has the entity user, event params user. Okay. Basically, we already know that it exists as a user, and I think we could safely delete this part. All right. Okay. And we change the entity to user. All right. We change it everything here. I think it's should be timestamp, and then we go and save the user information. All right, now we need to have all this information. We had this information about the user, okay, and now we will also add the increment ID information, which is going to be event. Again, we emitted the event with the field transaction hash to hex string, and we are going to add the index of the log. Then we define, we have defined the increment ID. Now we define the increment itself is basically a new or event of counter increment. Counter incremented, sorry. From schema, by the way, yeah, we will update the schema as well. We haven't updated, we haven't got the other few things here. We would need to import the begin library and the bytes library as well. It's a default libraries from Graph Protocol that you could get. Graph Protocol, Graph TS, and and again we here is all good. Count and command and user as well. We load them from the schema. The counter incremented here is basically what we loaded from the schema, and increment. All right. So for the increment, we need to store the user information to match that, and the new count that also comes from the events. We have it here. And then the timestamp again. And a few other things, which are block number at when this happened, and hash equal to event transaction hash. All right, and we save it to the database as well. So we so this subgraph it automatically indexes the contract events, right? We capture this data and we save the information about the user, and we save information about the increment that is connected with the user via its ID. So let's save it and hope that I haven't made any mistakes here. And we also check the schema. Yes, as you see, there are the schema is something that we will also need to update because by default it's generated by, but it was not automatically reading the user entity. The counter increment is fine, but we still need to get also the information about the user. I think ID, user, new count, timestamp, block number, block timestamp, and transaction hash is okay. And let's also add a user as an entity. Sorry, add entity. And an add field that is ID. And count, and last updated. And increments connected with the increment with the counter increment connected with the.
Hi, Asan. Can we zoom a bit more, please?
Sure, absolutely. Does it look better?
Yes, please. Thank you.
Yes. And connected with the counter increment via field user. All right. So SRC counter here is okay. Let's try to regenerate and see that I haven't changed anything. Let me see. Yep. All right. It's the small mistake here. Why did it work? User. It should be user. I think. Let me check. I think this is what it's. No. Okay. Yeah, I think I'm mixing this up in terms of the schema. All right. Let me check. last updated, and counter increment derived from field equal to user still. Okay, should be pretty much working, I think. All right. One parse error. String literal expected. Oh, okay, I think we need to still reinstall the dependencies here, right? Import. Oh, no, it's the small typo. Yeah, the small typo on my end should be good now. Still no. All right. I think something went wrong on the type generation. Okay, that's process image. Did I make any other mistakes? Let me quickly check. That user. We load the user. Opening, closing. Okay, should be pretty much good. Just not to take more of your time, let me simply ensure that everything is correct here. Build counter. I think, and generator answer. Yeah, I think. Okay, yeah, here we can finally see the error. It's the function handle counter incremented. I see. I renamed it, right? Yes. Okay. Yes, I renamed it and didn't change it. Okay. What's going on? Cool. Increments. Save. Increment transaction hash. Ethereum event. Oh my god. Something went incredibly wrong here. Let me see. User counter increment. I think it's okay. Here we will learn a lot of on how to actually fix this type of mistakes. Ethereum events entity ABI counter. Okay. Entities. Okay, we didn't add here the entity. We need to add it here because we were adding them, right? And here it's all good. SRC counter TS. The starting block is fine. All right. Yeah, all good now. No, still not doing that. Anyways, not to take more of your time, let's just simply go to the demo that I'm having as the prepared ones. I'm not sure what I did wrong redoing this live, but basically let's get to simply Somnia demo here and to the subgraph folder, the one that I generated previously. You could find it in the repository, and let's deploy it. The only thing that I will change here is that I will change the smart contract address to the one that we already know from the Remix IDE. Sorry, that's the block. And then the smart contract address is here. And the rest is good. Let's go and deploy it and deploy the new version. All right. All right, we have deployed a new version. Let me switch back to the API skills manager. You see that the new version of the subgraph is being indexed, and as you can see here, we already see the counter increments and users. Sorry again that something went wrong on my coding live, but basically this is the subgraph that you could still download from the repo. It's pretty much the same. All right, and the last thing is that we are having the application. The application is super fairly simple. It's just a demo, right? The demo is having the following flow. First of all, it has the counter and the leaderboard. The counter is getting the information from the subgraph, and it's incredibly fast. The leaderboard is fetching the information about all the users that have ever interacted with the smart contract, also via the subgraph, and shows the information in the sorted order. So this is the address. This is the demo that I have deployed yesterday for my existing smart contract, and now let's redeploy it to the new smart contract. All right. So I will just get my old smart contract information and give me a second. Nice. Yes, I will get to the development panel at the moment. Give me a second. I think I need to close this one. Nice. And all right, cool. So I will simply go through the whole repository and replace my old smart contract address with the new one and deploy it via the Vercel. The Vercel is just like pretty much convenient for deploying the static websites. Okay, and Let me go and deploy it.
Hi, Asadi. Can you zoom in a bit again, please?
Yes, yes, yes. Sorry about that. Well, actually, I actually can't in this application, sadly, but I will get back to the IDE at the moment, and I'm just stopping the screen sharing. And could I ask you, Manuel, to actually share the link to the demo application?
Awesome. Yeah,
Yes.
I'm making that
We will
public.
need to wait a few seconds before it updates via the Vercel.
Yes, it has been shared with the community, the live link.
Ah, yes. And mm-hmm. Snap. Okay, we will need a few seconds before it updates. Also, let me check. So, as you can see, guys, first of all, the subgraph that we deployed, the Somnia testnet counter, it's already synced. It is just like 30 blocks behind the chain, which is in Somnia terms is like just a few seconds. So, and we don't have any entities here. Let me see if our app has been updated. The app has been updated as well, right? So I'm going to click the increment counter, and I'm going to interact with the smart contract that we just deployed with you together. And we are waiting for the transaction to pass. We are getting the information, and we are getting it updated. Yes, please. Oh my God. Yeah. Everything that works before the demo doesn't work on the demo, right? Come
Yeah,
on.
that has demo gods need to be in our favor today.
Sorry?
So the demo gods need to be in our favor today.
Yes, yes, I'm checking. I think it should be pretty much working as expected, but it's not crazy enough. But okay, no, I think we're. Let me check. Yes, I think we are pretty much good. Maybe I think leaderboard. Okay, so I think it's just like the, it's my connection with the wallet doesn't work. Let me quickly disconnect and connect via another wallet that I'm having the access here. Uh, F0D. I see that if you are checking the smart contract itself, sorry, the subgraph itself,
Yeah.
we are seeing that there is one user that has interacted with the smart contract, which is funny enough is not me apparently, but somebody have already interacted there. Let me quickly check. Counter, it's 98A. What is going on? It's 98A. Sure. Why it's not 277? And I'm interacting with. Yeah, I'm interacting with the smart contract here. It is from 277 still. Why? Maybe I didn't update the website or something. Yes, yes, it was. It was just interacting with the wrong smart contract. That's the funny thing. And yeah, as you see, yes, finally. Sorry about that. It was just like I didn't update the website here, and it was taking a lot. It was interacting with the wrong smart contract. As you can see, my transaction passed, and like 2 seconds. There was no 2 seconds before the counter increased. What I wanted to show initially with this demo is how incredibly fast it is that the data is being updated after you see like less than a few seconds from the moment you interact with the smart contract to the moment that you actually get the results and updated. And what is even greater is that you are having the data nearly live nearly live, yeah, and you could construct the complicated queries that are providing, for example, here the leaderboard. And we are going to do a very, like, I know it's been already an hour, but let's do like for the last couple of minutes, like let's do a very small, funny exercise together. Let's do like a stress log. I see that Emmanuel has sent the application URL already. So I'm going to take 2 minutes here on my timer, and let's everybody who is still here, who is still with me, let's do the stress load for this application. Let's send as many transactions as possible and see how incredibly fast it updates. And after these 2 minutes, the one who is having the leadership is going to get a small present from us in the Somnia. So, guys, in 3, 2, 1, the timer is up, and I'm going to be participating as well. Just let's see how fast you are.
Okay, and the race is on the counter increment.
Yep.
Who it's going to get on top of the leaderboard. Away from today's demo session, we are still going to have this activity in the community and get everyone to participate as well. So this is just a very short and brief test on here.
I'm really curious, like whether somebody is going to actually write a script, because the one thing that is bottleneck here is that you have to actually sign the transaction. If you're going to write a script to sign the transaction fast, you will get the update like you could get on the top of the leadership very fast. But at the very same time, it's only 1 minute left, and if somebody is going to write the script and like be able to execute it in 1 minute, he will be able to get on top of the leaderboard with ease. But you know, it's kind of, I'm not sure somebody is that fast, really. But who
Yeah.
knows? Who knows? It's not really forbidden here. Okay.
These transactions are actually very fast. And
Yes, well, the Somnia is incredibly fast. I mean, like with this sub-second finality, just the amount of the transaction it takes, and the how fast it updates. You see, like with the subgraphs, you can get the complicated queries with less than like 5 seconds. I haven't seen, like, even today on the demo, I haven't seen the update that is less than that is more than 5 seconds, and it's amazing how fast Somnia is.
awesome, awesome. And I think this is a good opportunity to ask questions because we are way above time. Just before we leave, I just want to ask two questions. The first being, for developers building subgraphs, you did mention that they can either make their subgraphs public or make their subgraphs private. So for developers and make subgraphs public, does that mean that anybody can go on Somnia, go to the list of verified contracts, take a smart contract and build a subgraph for that smart contract, even if they don't own it?
Yes, so basically, even like since the chain is public and the information there is public, anyone, if you don't own this, the smart contract, but you know what it does and you know its API, basically, the API is, as I was saying, like the interface to the contract, right? If you know how it works, you can write the subgraph and you can fetch the data even if you don't own it. And this is the great about being public on the blockchain. So the way we develop this feature is that for some of the users, it is important to keep their subgraph private, so especially when it's in development, uh, to not to expose your work. And so you could keep it private or you could post it publicly. And then if you post it publicly, the subgraph on Somnia, so you could go to to somnia.chain.love yourself, right? As I was seeing here. And on the all subgraphs, there are subgraphs that are not deployed by me. For example, like I know that there are a couple of projects like Credit Arena here that has deployed the subgraph with us. It's not my subgraph. I can't. You see, I don't have the buttons here to control it, but I can query it. I can get some. I don't know what is borrows, but I can get some borrows and get the actual information. And anyone of you can do it live, and you can switch between the version, but you can't control what you do with the subgraph because it's not your subgraph. And you can actually get the code of the subgraph because it's kind of the property of the user who it's the property of the user, right, who deployed the subgraph, but you can use it freely. And this is amazing because you could base your work on the subgraphs that already exist.
That is amazing. And then talking about what you just mentioned during the course of that, about how easy it is, what would you say is the simplicity of it for developers who are not even Web3 developers, how easy it is to start building out subgraphs?
Well, as I was saying, you see, like on the demo, the guts of the demo didn't was not kind to me, sadly, today. So I mixed up and I was a bit stressed. I think I made some super silly, stupid mistake that it didn't work. But as you saw, the command that is graph init, it generates the structure of the subgraph. And if you want to build something on top of it, some logic on top of it, right, you can do it yourself manually, and then it's more complicated. But if you have like the smart contract even written by somebody else, you could simply have the smart contract address, write the graph in it, and it will generate the initial core structure for you. As simple as that. And you don't even need to know how to code. It's more of like, this again, like the whole application that is there. I'm not like a huge, like super duper senior developer myself. I'm the guy like mostly focusing on the DevOps infrastructure things, and I was able to vibe code it with the AI yesterday in under like 20 minutes, so 20-30 minutes approximately, like that, easy.
Awesome.
So yeah.
That is delightful to hear. And usually, when we have guests on here, we typically ask what would be your advice for developers that want to like start creating subgraphs almost immediately. How do they begin?
You just get to the website, right? We have a very good documentation here about how to use our solution, and we have an information about how to actually build the subgraphs. Like there is this, sorry again for clicking, there is this button documentation, right, that leads to our docs, and here you have all the information on how to create your first subgraph. This is like provides you whole information about how to initialize it, la 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 la. Also, I saw that you were sending the link to instruction on the Somnia documentation, and like I was reading that a couple of weeks ago, and I think it is amazing. It's also like pretty much step by step. So if you want to figure out how to do at least basic things, you can start from there, and I think this is a great source of truth. Yeah.
Awesome, awesome. Thank you very much, Aseni. This has been a very delightful session, and I think it's a great way to close out today's session. So
I
just
think
before, yes,
I
please go
think
ahead.
we could finalize the leaderboard now then, and the one who is on top is ending with F03. I'm not sure whose wallet is that, but congratulations. Sorry.
I said nice. How nice? Awesome.
Yes. So that's a pretty much real life update on how we build the subgraph and use it immediately to get the information from the Somnia network in nearly lifetime. I think like this is really great for building the lifetime application. For example, one of the things that I was thinking about writing right today with you, it was more complicated. That's why I didn't want to overcomplicate this demo, but one thing that came to my mind is right in the chat, online chat that is fully on chain. With Somnia, it is real. With majority of other networks, not, because the blocks there are way too slow and you can't really use the chat. That then you need to wait like 2 minutes to actually get your message sent. Here, it will be a sub-second thing. Like you write the message, it's immediately there, it's updated, you get it. It will be no different from any other chat, but it will be fully on chain with Somnia.
That is amazing, right? And it goes to without saying that the speed of Somnia is actually what makes that possible, right? And also the core tech that you have built at Protofire also makes that a seamless experience. Because one thing that we have experienced is having tooling services not being able to keep up with the speed of Somnia, and having a tool that keeps up with that speed is actually very, very interesting.
It was actually a great challenge for us. Initially, when we deployed our solution, like back in the couple of months ago when we started to work with you guys, right? We were delayed by 10 minutes all the time because the blocks are incredibly fast, and we were like, what should we do? And it took us a great amount of effort to actually to make sure that this tool is up to speed with the indexation is up to speed with the Somnia network. And this is amazing how Somnia sets the completely new standards that we need to follow.
Exactly. Sonia sets the completely new standards that everyone else needs to follow. You heard it here first from Aseni, and it has always been said. Aseni, this has been a very, very delightful experience. It's been a pleasure having you on, and I hope we get another opportunity to do this sometime soon in the near future.
Yes. I hope as well. It was my pleasure, Emmanuel, today, and I really loved being here with you guys. And thank you for your attention. Again, sorry that not everything worked out as I expected it to work, but then again, please refer to the materials that I sent. It has all the information about how it was written. I also like it has the great commands, great. Like step-by-step instruction on how to deploy it. So just go and do it and test yourself that it works as expected.
Awesome, awesome. All the resources are there in the comments. You can find the link to the good GitHub resource that's Aseni just spoke about, links to the documentation as well, and it's also available for YouTube on YouTube. And also, you can go on YouTube to rewatch this video and set it at the pace that you would watch it and get to learn. Thank you once again, Aseni. With that, we'll bring to this session to a close. And bye, everyone.